But yeah, we were celebrating one of our stepbrothers' birthdays, and we were on the beach, and we had a bunch of beer, and then we actually ordered pizza, and they delivered to the beach.
To the beach, of course.
So there was like 7 boxes of pizza showed up right when everyone was super hungry. It was awesome, and like we just chill on the beach. We actually got to the beach at like 4:30, and then we were there until like 11 o'clock at night.
Oh, wow.
Yeah, smoking stogies, eating pizza, drinking beer.
Is it still crowded? Like once
No,
the sun goes down?
Definitely not. No, we're
And
like we want to be the last ones on the beach.
And
So
you can booze, and they don't.
yeah,
they don't
they
care.
don't care. I mean, I don't think you're supposed to, but they don't care.
Nice,
it's pretty fun. And then we got this ice cream. They have this great ice cream store. It's ridiculous. When I go there, I just like turn into a different person. There was this sundae called the Fluffernutter. It's like peanut butter ice cream.
Oh man!
I saw him making it. I was like, oh my God, is that for me? It's embarrassing. 2 things, scoops of peanut butter ice cream, peanut butter drizzle. It's like basically liquefied peanut butter. They drizzle on it, marshmallows in it, and then whipped cream. It was amazing.
And you ate it all. You were like scraping the bottom.
I actually took off the whipped cream and some of the marshmallows, but the rest I ate for sure. Next time I'm gonna do 1 scoop of peanut butter in a waffle cone with the peanut butter sauce on it. I think that's enough.
Good.
Yeah. The sundae's a little overkill. Yeah, I'm like a different person there. You know. It's like all my healthy habits go out the window. I'm so regimented during the week.
Beach Sam.
And then I like get to the beach house. I'm like, where's the first beer? All right, we got to go make sure we have a few cigars for the weekend. Make our first stop at Avalon Freeze. All right, so we have a bit of a time constraint today, but we wanted to try something a little new on this show. And we want to discuss this really excellent blog post. It's about APIs, but it has a ton of overlap with a lot of the stuff that we discuss when it comes to data loading and distributed data and SPA development. So it's dense. There's a lot here, and I've read it twice now, and so we're going to read it kind of again together, and I think I'll get even more out of it the third time. So it's just one of those articles that's kind of worth revisiting. I really appreciate that Steven Wittens, the author here, put this together because it's just a really interesting. The guy obviously has a ton of experience with this stuff, and he's written it up in a really nice way that's kind of accessible. It's kind of entertaining, but it talks about a lot of good stuff. So yeah, if you haven't seen his website before, it's that website with that header, which I actually found this website like when I first got into development, because it uses this really cool like WebGL canvas thing at the top, and yeah, he's like one of those cool websites that's just been around for a while. He's been around for a while. So all right, without further ado, this was written July 26th of this year, so pretty recent, and it's called APIs Are About Policy. So I think we'll just this is our first time doing this, but it's kind of an experiment, but I think I'll just read it and we'll just kind of periodically stop and discuss it. So the intro: the web is a system, Neo. That system is our enemy. But when you're inside, you look around. What do you see? Full stack engineers, web developers, JavaScript ninjas, the very minds of the people we are trying to save. But until we do, these people are still a part of that system, and that makes them our enemy. You have to understand, most of these people are not yet ready to be unplugged. And many of them are so inured, so hopelessly dependent on the system that they will fight to protect it. Were you listening to me, Neo? Or were you looking at the widget library in the red dress? What are you trying to tell me? That I can dodge unnecessary re-renders? No, Neo. I'm telling you that when you're ready, you won't have to. This is great. It's actually great because it's not just like a meaningless thing. Once you actually understand the article, there's lots of nuance in this. So this is great writing. So the intro here, it says, the web is always moving and shaking, or more precisely, shaking off whatever latest fad has turned out to be a mixed blessing after all. Specifically, the latest hotness for many is GraphQL, slowly but surely dethroning King REST. This means changing the way we shove certain data into certain packets. This then requires changing the code responsible for packing and unpacking that data, as well as replacing the entire digital last mile of routing it at both source and destination, despite the fact that all the actual infrastructure in between is unchanged. This is called full stack engineering, available for hire now. that's kind of interesting right off the bat, right? Because there is an aspect of kind of the innovations in API development over the last few years that touch the transport layer, but you know, you still have a Rails backend and you still have an Ember front end or whatever. So it's like at a 30,000 foot view, it's like, what have we actually accomplished?
I don't know if that's fair.
All right, well, we'll see by the end of the article if he can convince you. The expected custom and indeed regular pastime is, of course, to argue for or against the old or the new. But instead, I'd like to tell you why both are completely wrong for small values of complete. You see, APIs are about policy. All right, so now we're into kind of chapter 1, RESTless API. Take your typical RESTful API. I say typical because an actual representationally straight transferred API is as common as a unicorn. A client talks to a server by invoking certain methods on URLs over HTTP. Let's go with that. Optimists will take a constructive view. The API is a tool of empowerment. It enables you to do certain things in your program you couldn't do before. And that's why you're importing it as a dependency to maintain. The more methods in the Swagger file, the better. That's why we call it a Swagger. So Optimus will take a constructive view. He's saying people look at APIs as things that enable their program to do new things.
Yeah, I agree with this too, right?
But instead, I propose a subtractive view. The API is a tool of imprisonment. Its purpose is to take tasks that you are perfectly capable of doing yourself and to separate them from you with bulletproof glass and a shitty telephone handset, one that is usually either too noisy or too quiet, but never just right. Granted, sometimes this is self-inflicted or benign, but rarely both. I gotta say, he like really captures the feeling of like the web development in these like single sentences in a way that's hard to really put into words.
Yeah. Well, I mean, just what you just read reminds me of having a JSON API backend, which feels great until you need to do transactions. And then you have that feeling of bulletproof glass.
Right.
That I can literally not get through this thing. And
I put myself in a straitjacket almost.
Yeah. So that really hits home.
Yeah. So he's basically saying, right, optimists take a constructive view. API is a tool of empowerment. Instead, I propose a subtractive view. The API is a tool of imprisonment. And kind of he'll elaborate more on this in a little bit. This is also why there are almost no real REST APIs. If we consult the Book of Difficult to Spot Lies, which is a link to Wikipedia, we learn that the primary features of a REST API are statelessness, cacheability, layeredness, client-side injection, and a uniform interface. Let's check them. Statelessness means a simple generality. URLs point to blobs, which are get and put atomically. All the necessary information is supplied with the request, and no state is retained other than the contents saved and loaded. Okay, so basically like a get to user one with any kind of headers. When we say HTTP is stateless, that's kind of what we're saying. The request is kind of has self-contained.
Yeah, doesn't matter what order I make this request in. Always going to get the same response back. Yep.
Right. Multiple identical gets and puts are idempotent, which means they can happen again and again, and the same result will happen.
Yes.
The delete verb is perhaps a put of a null value. So you're kind of like putting a null object to indicate that you're deleting the resource. So far, mostly good. The patch verb is arguably a stateless partial put and might be idempotent in some implementations, but only if you don't think about it too much. So put generally is like replacing an entire resource, and then a patch is like modifying part of it.
Yeah, I think so. I mean, in every web app I've ever worked on, put and patch are basically aliases of each other.
Yeah.
And they both are partial update.
Yeah.
That's how. So, but yes, I think that's the way. What you described is like the true way.
Yeah.
I also think this is where it's starting to break down.
Right.
We don't really use REST.
Right.
Yes.
Yeah. I remember seeing a talk recently of Chris Toomey from Thoughtbot saying like, oh, we finally 5 years later in Rails now have like patch as a default thing, and nothing has changed. So only if you don't think about it too much, which means a huge part of what remains are post requests, the bread and butter of REST APIs. And those aren't stateless or idempotent at all. So I found this really interesting. First of all, post request being the bread and butter of REST APIs. Like, I think if you would have asked me what's the bread and butter of REST APIs, I wouldn't have just said that. But him saying this kind of was thought provoking. They're not stateless and they're not idempotent. So why aren't they stateless? Because they depend on state, namely the state of the database. So when you create a new user with a post request, like what ID it's going to get depends on the database, as a very simple example. So it's not stateless. Also, if you were to post the same like name Sam Selikoff post request and then post it again, you're going to get two different things back. So it's not idempotent.
And yeah, not only that, like imagine having an email address in there. Like the first one is going to 200 and the second one's going to fail because it's going to say this email address is already taken.
Right.
Right. So yes.
So not stateless, depends on the database, not idempotent. You can't do it over and over again and have the same result. Cacheability and layeredness, i.e. HTTP proxies, in turn, have both been made mostly irrelevant. The move to HTTPS everywhere means the layering of proxies is more accurately termed a man-in-the-middle attack. That leaves mainly reverse proxying on the server or CDN side. So maybe you can help me understand this. I was Googling a little bit about this.
So I think you know, I'm going to try to be charitable here, but you could imagine like, I probably won't be. You could imagine like back in the old days, like you have an ISP and that ISP, like think about how like Netflix works, where that ISP, you just read this page on Wikipedia, so they're going to cache it at their data center. And then when I go pull up that page, I can just read it from like the ISP's cache. I don't have to go all the way route
to
all
origin.
the way to, yeah, exactly.
So that's a proxy server.
Yeah,
because
that's like
the clients are accessing the proxy server, which then makes the request to origin.
Yeah, and so you can think of like Netflix works like this, right? Netflix doesn't want all the clients routing through the whole internet. They'll like ship like a server to ISPs that hold all the videos on it, so they don't have to do that. But let's go back to this Wikipedia example. You make the request, your ISP sees it, they go to Wikipedia, they get the article, but then they cache it. So then when I make the request, we're on the same ISP, I can just get it from the ISP. The ISP doesn't have to go to Wikipedia, and we just save the internet a whole bunch of bytes.
Mm-hmm.
The one problem now is like everything is HTTPS. So the ISP has no idea what article you're pulling from Wikipedia. They just see you're making a request to Wikipedia's server.
But it's encrypted.
But it's all encrypted. So they can't cache it. They don't even know what you're reading from Wikipedia.
Oh.
So when I go off to get this article from Wikipedia, even though they just served it to you, they have no idea that, first of all, they don't even know what they served to you because it was encrypted and only you and the server have the keys to decrypt it. So this whole idea of like, oh, we can set up all this caching infrastructure all around the internet to act as nodes that cache, like that's not true anymore. And if you did that, it'd be considered like a man-in-the-middle attack because you would be like, peeking into your things.
Yeah. I totally missed that. I didn't understand that.
It's funny, like this thing that should be helpful is actually evil and it's trying to steal all your data. So
interesting. Okay, so layering of proxies is more accurately termed man-in-the-middle attack, leaves mainly reverse proxying on the server or CDN side. So again, the reverse proxy, let me see if I can explain this to make sure I understand it. So one thing I read, I think helped me finally clarify. The proxy is the ISP because multiple clients, even let's say like in this WeWork, we have two computers.
Yeah.
And when we make a request to twitter.com, which we do often, we have two clients going there. But by the time twitter.com gets a request from like the ISP that WeWork building is going through, twitter.com doesn't know if it's my computer or your computer, unless like the proxy server decides to forward along headers or something like that. But basically that ISP could obfuscate it. So the server, Twitter in this case, doesn't know what the clients are.
Yeah. I mean, okay, but
it doesn't know what the clients are.
I'm going to be pedantic. You're absolutely right. But like your tweets are different than my tweets. So Twitter would want to know what the clients are because they're going to serve you a different feed than me. That's why I think Wikipedia works well here because like Wikipedia is basically the same for everyone.
I see. Okay, so right, let's say we do that and let's say you strip all headers that could have any identifying information.
Yep.
You could theoretically do that,
yes.
And then Wikipedia literally wouldn't know.
Yes.
Reverse proxy is literally the reverse, where instead of the server not knowing who the clients are, the client doesn't know who the servers are.
Yes. Yes.
So the client makes a request, and we hit, Google's front server. It's reverse proxy, and then that thing can do things like say, "Oh, should we forward this request to server 1? Oh, it's overloaded. Let's go to server 2." So us as the client don't know that we're talking to server 1 or server 2.
Yes. Very, very nicely put.
That kind of made me really understand. So that's why it's called a reverse proxy, because it's reversed. So we say that leaves mainly reverse proxying on the server or CDN side. The HTTP cache control headers are also completely backwards in practice. For anything that isn't immutable, the official mechanism for cache invalidation is for a server to make an educated guess when its own data is going to become stale, which it can almost never know. If they guess too late, the client will see stale data. If they guess too soon, the client has to make a remote request before using their local cache, defeating the point.
I mean, this is so true. This is even true from this is definitely true with HTTP, but it's also true with Ember data.
Yeah.
Where it's we want to cache things in Ember data. We want fast lookups if we've already, downloaded the models. But then
you don't want us to show stale data.
Yeah.
And stale data is a problem that comes up all the time.
Yeah. And I remember we had this conversation, or I had this conversation with Luke maybe a year ago, but he said something like, yeah, every time I try to implement this in Ember data, I get this wrong.
It's because we were
so true.
So true. We were toying with the storefront APIs where we say expires in 5 minutes or whatever. And he was like, what are you going to put there? It's so arbitrary. And also the server knows best, right?
Yep.
Now, there's so many things here, right?
Well, what I think most web apps do today is sort of what I'll call the varnish or Fastly model, where they have something closer to the front of their load balancer that caches all the data, and then has a way to get told that the data is out of date. So it doesn't eliminate HTTP requests. The client is still going to make HTTP requests, but it eliminates the sort of need to go to a database or routing through your whole backend layer.
Right.
So with us, we do this, but yeah.
Right. So here, let's finish this paragraph, and then I think there's more to discuss. So if they guess too late, the client will see stale data. If they guess too soon, the client has to make a remote request before using their local cache, defeating the point. This was designed for a time when transfer time dominated over latency, whereas now we have the opposite problem. So for a time when transfer time dominated over latency, meaning... whereas now we have the opposite problem.
So was transfer time? It would mean it would take me a long time to download an Ember data model.
Right.
And now it's really fast.
Right.
Where with latency, it's
the actual request?
Yeah, I guess reading from something is slower if I'm reading it from the back end. But why would that be? I don't understand why that would be reversed.
This was designed for a time when transfer time dominated over latency, because you wouldn't want to have to re-download something because it was so expensive. So the cache on the client was more important. Whereas now re-downloading an Ember data model is cheap, but and you can ask things quickly, right? So it's not that downloading a model is expensive,
right?
So that's why I think that's what he's saying. Common practice now is actually for the server to tag cacheable URLs with a revision ID, turning a mutable resource at an immutable URL into an immutable resource at a mutable URL. So can we think of an example of this? So let's say a revision ID. What kind of thing do we use for a revision ID? Like an image or an asset, like a JavaScript asset with a hash on the end of the file?
Yep.
Okay, so that's now it says a mutable URL.
Yeah.
Okay, right. So you build the JavaScript or index. Let's say JavaScript, right? App.js, which is a immutable URL, and app.js would change. And then you have this question of how do you bust the cache? Whereas now we just turn it into app.js hash 1, 2, 3, 4, 5, 6, 7. That thing's immutable. It's never going to change.
Right.
And so the thing that loads it will point to different URLs as the resource changes over time.
Right. So the app.js is mutable, but we put it on an immutable URL.
Right. And so again, just to kind of zoom out this paragraph, there's a lot in here, obviously. It started off talking about cacheability and layeredness, in turn have been made mostly irrelevant. And the point here is like the cacheability of a REST API, and this can apply to like JSON documents as well, right? It works well when a get is idempotent and stateless, and it's the same thing every time. That's when caching works best. But if you're going to change it over time and bust the cache, it's like pointless because you're just changing the location of it.
Yes.
So it's not as important. It's good to cache things that are the same. Obviously, that's a benefit. But I think his point is like, let's go back and just read this. The primary features of REST API are statelessness, cacheability, layeredness, client-side injection, uniform interface. So he's saying cacheability has been made mostly irrelevant. That leaves reverse proxying on the server side. And then the HTTP cache control headers are also completely backwards in practice. Okay, so he's saying, this is the point, right? For anything that isn't immutable, the official mechanism for cache invalidation is for a server to make an educated guess, which it can almost never know. So a cache control header, the whole notion of a cache control header that says this expires in, right? That's what that's like useless. Right. He's basically saying it's wrong. It's backwards.
So to get around that, you say this thing never expires. Right. It's immutable.
Which means the header is pointless.
Right. Yeah. And
there's no reason for it.
You create just a brand new URL.
Yeah.
Each time it changes. And then you update index HTML to point to new URLs.
Right.
Okay.
So basically HTTP cache control headers are useless.
Yes. Yeah, it makes sense.
It makes sense.
Because I guess it would be better. There's basically never cache and cache forever.
Right.
And everything in between doesn't make sense.
Right. Exactly.
Yeah.
Exactly. It's pretty interesting. Also, going back to the conversation with Ember Data with Luke, I remember him saying, we were kind of toying with this, which is like, oh yeah, it expires in like 3 minutes. Like maybe on a site like EmberMap, I can say, it expires in a day. And it's okay if you see something a day old, but if you're browsing the site, you've had it open and you have like all of our videos cached, like we should give you updates in a day. And that seems reasonable, but it is wrong, right? Yeah. I mean, it is wrong. And in this case, the server knows that is whether it's expired or not. And Luke kind of said something. He was just like, I just always want the latest data. Like I always just want the latest data. Like, and we kind of talked about Firebase where you basically have a subscription to the back end and you just are always working with the latest data. I think we're going to find out that's also not the right way to think about it, because even though it's ideal, the reality is we're working in distributed environments. So you just you can lose internet, right? Offline capability, all that kind of stuff. So that kind of complicates the story. Mm-hmm. Okay, so this paragraph makes a lot more sense to me than the first two times I read it with the man-in-the-middle thing with the layeredness of the proxies and the cacheability. So that's kind of interesting. Cache control headers are basically a Boolean.
Yeah.
You really want to say this thing is immutable or not. Okay, so now we're on to client-side injection. Client-side injection, on the other hand, is obviously here to stay, but still, no sane REST API makes you interpret JavaScript code to interact with it. That was mostly a thing Rubyists did in their astronautical pursuits to minimize the client-server gap from their point of view. In fact, we have entirely the opposite problem. We all want to pass bits of code to a server, but that's unsafe, so we find various ways of encoding lobotomized chunks of not code and pretend that's sufficient.
Yeah. Wait, what is, can we just back up? What is client-side injection? Like, what is a...
Client-side injection, I guess he's saying, if you design your API in a way to expose the ability for the client, any client, to run arbitrary code against your data, you expose yourself to client-side injection, which is like any sort of third party, unknown party injecting that code into the client script. And so that's why, as a matter of policy, you, on the server's perspective, don't allow arbitrary code to be run.
So like it sure would be easy if we could just write SQL in our JavaScript apps and have it fetch. But we don't do that because like, doesn't he say we don't do that because you could run code? And then what does he say? He says something about like what was like the last sentence in
In
that
fact,
paragraph?
we have entirely the opposite problem. We all want to pass bits of code to a server, but that's unsafe.
Right.
So we find various ways of encoding lobotomized chunks of not code and pretend that's sufficient.
That's it. So like we would, instead of writing SQL, we'd come up with like some URL format like includes post.
Exactly.
It's like a lobotomized joint statement.
Yes, exactly.
And so, okay. Cool.
Yeah. And he's going to go into this a little bit more, but yeah, that's exactly right. And basically, client-side injection is here to stay, meaning like we have clients, iPhone apps. I mean, even a Rails app, right? The client is the computer, so making a request, even though it's not as like hard boundaries with like an SPA, like an Ember app. But that's here to stay as long as you have an unknown client making a request. You have to enforce a policy. That's basically his whole thesis. Because that client-server thing is here to stay. Client-side injection is a problem. He's basically getting at like why it's about policy. So he'll unpack it soon.
Okay.
Okay, pretend that's sufficient, which leaves us with the need for a uniform interface, a point best addressed with a big belly laugh and more swagger definition file. Take the most common REST API of them all, and the one nearly everyone gets wrong, /user. User accounts are some of the most locked up objects around, and as a result, this is a prime candidate for breaking all the rules. The source of truth is usually something like this. So he has a table here, and there's 2 rows in it. It's literally like 2 rows in a database table. There's an ID. The first row is ID 1, email admin@example.com, handle is admin, real name is John Doe, password hash is a hash. Picture is a URL to s3://bucket/1.jpg. Karma is 5 and admin is true. And then there's a second row, ID 2, email jane@example.com. Handle is Jane, real name is Jane Doe. Picture is also URL, karma is -3 and admin is false. Okay, so he says that's the source of truth usually, right? He says, but if you do a get to /user/2, so the second row, you likely see this. And so we see a JSON object here. ID is 2, handle is Jane, picture is s3:bucket/2.jpg.
Yeah, and I think the big thing here is like you don't see the whole database, and you especially don't see the sensitive parts. So you don't see the password hash, and you don't see the email address.
Right, all public information. Unless you're Jane Doe, you do a get to /user/2, you see ID 2, email jane@example.com, handle Jane, name Jane Doe, and then picture. So you get the actual name in the email.
But not the password hash. Because no user needs their own password hash.
Unless you are John Doe, the admin, who gets all the original plus the karma of -3 plus admin is false. So right there we have 3 different representations basically of this one database row. What is supposedly a stateless, idempotent, cacheable, proxyable, and uniform operation turns out to be a sparse get of a database row, differentiated by both the subject and the specific objects being queried, which opaquely determines the specific variant we get back. People say horizontal scaling means treating 1 million users as if they were one, but did they ever check how true that actually was?
Really great. Also, super hits home because EmberMap has the same thing where it's like if you're an admin, if you're the user, if you're on the user's
video
team,
you get.
No, just a user, just a
user.
user record. Like if you're an admin, you can get the full user. If you're the user that's requesting the user, you get more info. If the user's on your team, you get more info. If the user's not on your team, you get very locked down. Basically nothing. So yeah.
And then if you're not on...
and if you're not like even
associated with them...
that's a lockdown version.
Yeah,
you basically just get the ID back.
Right.
But this is like... Yeah, I remember coding this. I remember writing all these test cases. And I remember not thinking about this beforehand.
Yeah.
And it was just, this really hit, like there's a lot of code around all this.
Yeah.
So.
Yeah. It certainly doesn't feel like the conventional parts of the API.
No,
as opposed to
fact,
like compared to like the objects in our system that are truly, these things, right? Stateless, cacheable, a public blog post. It's like, it's the same for everyone. It's
that's
the same for everyone.
Yeah, that's a good point. I don't know when I coded that. I don't know if I ever made that connection. I just kind of figured like, no, this is how it has to be. This is like the rules of our application. and therefore I have to, like, I can't just show all users, right? So I have to, like, I don't have a choice here. I have to code this.
But you're not thinking like, oh, I'm breaking REST in some sense.
No,
like
not at all.
The policy change is like breaking REST. You could actually imagine, what would it look like to shoehorn this policy into a RESTful interface where you have like literally a different object for each view of that thing. And then that thing is truly like cacheable an item or whatever, right?
It looks like a lot of Ryan complaining. That's what it looks like.
Yeah, exactly. And that's not even like, he's going to go on to say it's not really even a worthy goal, because like APIs are not about what we say they are.
Yeah. Also too, on this, I just want to say, when I started reading this article, and I felt like, I was like, no, like we use Rails and we use JSON API and we use Ember. Like, of course we have a RESTful backend. Like, of course, like, right? Like JSON API gives us all this stuff. Rails makes it easy to write REST. When I got to the end of this part, the part that you just read, I was like, yeah, obviously we don't have a RESTful backend. But it really, like, it just, I was kind of defensive at the start, thinking like, no, my tools actually allow me to have REST. And this was a point where I was just like, nope.
Yeah.
The wall is falling apart here.
Yep. I'm not done yet, he says. These gets won't even have matching puts, because likely the only thing Jane was allowed to do initially was post to /user with name Jane Doe, email jane@example.com, and password 102. Note the subtle differences with the above. Point 1. She couldn't supply her own picture URL directly. She'll have to upload the actual file to S3 through another method. This involves asking the API for a one-time permission and the details to do so, the signature in our case with Amazon, after which her user record will be updated behind the scenes. So he says, really, the type of picture is not string. It is a bespoke read-only Boolean wearing a foreign key outfit. I had to read this a couple times. So a string column is like a string. It's like a name. You can just change it.
Yeah, I can put to it. Yep.
Exactly. You can put to it. It's not really a string, even though it is a string. It's a URL. It's a Boolean, which is either you have it or you don't, masquerading as a foreign key, pointing to a resource on Amazon servers.
Yeah.
And it's like really invalid if that thing didn't exist on Amazon servers, right?
Yep.
But like there's nothing about, that's like a implicit, all implicit.
Now, I guess you could, I mean, again, I guess you could have like a validation where if you try to put something that's not on S3 that like you didn't upload to
but that's
S3.
The point is like you can't just update it. Like there's other logic.
Yeah, there's other, yes. Oh, right.
That's the whole point.
Right. Because you'd want to say like, right. I can insert any data into my database. My database is never going to tell me you can't insert a string into the string column.
Exactly.
But now we're in a situation where we have a string field that you can't just use strings in.
Exactly.
Yep. Very good.
Point 2. She didn't get to pick her own ID either. Its appearance in the get body is actually entirely redundant because it's merely humoring you by echoing back the number you gave it in the URL, which it assigned to you in the first place. It's not part of the data. It's metadata, or rather the URL is. See, unless you put the string /user before the ID, you can't actually do anything with it. ID is not even metadata. It's truncated metadata. Unless you're crazy enough to have REST API where IDs are mutable, in which case, stop that. So that's pretty interesting. Like, I had to read that a couple times too, but like an email makes sense on its own. sam@embermap.com makes sense, but like an ID doesn't. It's truncated metadata.
Yeah.
It's like user one.
Yes.
That makes something.
Yep.
Makes sense. But you're getting ID back as a field.
Right.
And it's so, it's like, again, it's just it's a special case. It's a special case of the data structure. Point 3, one piece of truth data, the password hash, actually never appears in either gets or posts. Only the unencoded password, which is shredded as soon as it's received and never given out. Is the hash also metadata, or is it the result of policy? Patch to /user/1 is left as an exercise for the reader. But consider what happens when Jane tries to change her own email address. What about when John tries to change Jane's? Luckily, nobody has ever accidentally mass emailed other customers by running some shell scripts against their own API. That's really interesting, right? Because like when my first job writing Perl scripts, that was just like pulling data from a database. There is no policy there. So you are writing a Perl script that's going to select star from users, select, email from users, and you have everything. There's nothing holding you back. Whereas like when I work on the front end against like a Rails API that you built, I'm like, I don't care. I know it's secure.
Yeah.
We have it tested and we have policies in place.
It's even more than secure. You just know that all the data you get back is all the data you need.
Or that you're allowed.
Yeah.
Or that the user is able to view.
So when you're like eaching over something in a template, you're just like, okay, just render this. I don't need to check anything. And it would feel weird also to like check if you can render this thing in a template, because at that point it's like, wait, I'm already at the template. I already have this thing in my store.
Right.
So I better be able to render in the template, because if I can't, we have a major problem.
Exactly. Totally. So yeah, luckily nobody has ever actually mass emailed all their customers by running some shell scripts against their own API. It's interesting to think about that, right? Like,
yeah.
Oops, I selected, I did a get to /users and I got back something I shouldn't, and then I sent an email out to them, Neither from the perspective of the client nor that of the server do we have a /user API that saves and loads user objects. There is no consistent JSON schema for the client, not even among a given single type during a single stateless session, nor idempotent whole row updates in the database. Rather, there is an endpoint which allows you to read or write one or more columns in a row in the user table, according to certain very specific rules per column. This is dependent not just on the field types and values, i.e. data integrity, but on the authentication state, i.e. identity and permission, which comes via an HTTP header and requires extra data and lookups to validate.
Yeah.
If there is no client-server gap, you just have the data you own fully and which you could manipulate freely. The effect and purpose of the API is to prevent that from happening, which is why REST is a lie in the real world. The only true REST API is a free-form key value store. So I guess S3 and CouchDB could qualify, but neither's access control or query models are going to win any awards for elegance. When correctly locked down, CouchDB2 will be a document store that doesn't return the same kind of document contents for different subjects and objects, but it will at least give you a single ID for the true underlying data and its revision. It will even tell you in real time when it changes, a superb feature, but one that probably should have been built into the application session transport, whatever this layer is, as a subscribe HTTP verb.
Interesting. I feel like there's two things there. I want to go back to the first, where before he talks about Couch or S3, and just saying, I think this is what kind of you've been saying this whole episode, but the whole point of the API is about controlling who can write what data to what fields. So it's like the person, the record, and then also the column. And that's a whole thing the API needs to control. Those are all the things the API needs to control. And that if you look at EmberMap's API, like that's what all the code is. All the code is, what do you have access to read? What do you have access to write? What columns do you have access to read and write? So that I like what he says, but it's also like I feel it.
Yeah.
Right? Like if you pull up our API, that's what you're going to see. You're not going to see things like transforming database records to JSON.
Yeah.
You're just not going to see that in any of our API code. It's going to be all, checking auth and checking validations of data getting inserted.
It's really interesting. Also, like as we've built higher and higher abstractions on like kind of the first PHP app we ever built, and then like Rails apps, more and more of the kind of incidental stuff gets abstracted away into libraries and stuff. But even if you go back to like a Rails app and like you're building a web app, and like it boils down to the same essential thing. Why don't you, you're making a new website for project management software. Why not just give people a blank Excel sheet or a blank database and teach them SQL? Like why? Because you want to, it's so that you can enforce who changes what about what data type. And it's funny that's basically the essence of it, right? Very interesting.
Yeah.
Was there something else you wanted to say? Maybe CouchDB or S3 or anything? You said you had two things. Maybe.
Oh no, I've just there were two. I wanted to address the first part of that. I don't know anything about Couch.
Yeah,
and I'll just laugh at the S3
bucket document store
access policies, whatever he called out.
Right.
So,
Right. But yeah, that kind of makes sense, right? He's saying really, you want to see what a true REST API looks like. It's like an empty bucket with no rules anywhere that you can just, the client has control to put a resource, to delete, get the same thing over and over again, which is like the most useless thing ever from the perspective of someone who wants to make a web application.
Yeah. Okay. Yeah.
Right. That's kind of his whole thing, is like, it's actually, here's how we violate REST in all these 10 ways. It doesn't matter because that's not actually what we care about. Like, it's not actually useful to us as application developers. Couch is the exception, though. In the usual case, if you try to cache any of your responses, you usually have too much or too little data, no way of knowing when and how it changed without frequent polling, and no way of reliably identifying, let alone ordering, particular snapshots. If you try to put it back, you may erase missing fields or get an error. That sounds familiar.
Yeah.
No way of knowing when and how it changed without frequent polling. No way of reliably identifying, let alone ordering, particular snapshots. And if you try to put it back, you may erase missing fields or get an error. So what if we both hit edit on an EmberMap video, you change one field and I change another, and then I save mine, and then now you save yours?
I win.
You win.
Last right wins.
Last right wins. Plus, I know your Express server spits out some kind of e-tag for you with every response, but without looking it up, can you tell me specifically what that's derived from and how? Yeah, I didn't think so. If that field meant anything to you, you'd be the one supplying it. Can you unpack that a little bit?
Yeah. So I think, so you have e-tags. E-tags are the client, the server can give you a response and then give you an e-tag, which we'll just say is like a hash of the body of the response. And then the next time you make a request to that resource, you can say like, hey, I want all users, and my e-tag is 1, 2, 3, 4. And the server can then generate the response for users, hash it, see that the hash is like 1, 2, 3, 4, and then tell you it's like 304 not modified. It can tell you 304 not modified, and you can say, okay, I can just use the data that I have stored locally that matches this hash, and therefore that giant user's payload doesn't need to go over the wire. So it's like a shortcut.
But he's just saying it's not a way to avoid this whole caching problem.
Oh, no, not at all. And in fact, it's like generating. So this might be back to the latency versus download time, but generating that e-tag is the expensive part. Once I have the e-tag, I've got all the data. I can just send that to you over the wire. But generating the e-tag, like in Fastboot, for me to generate an e-tag of a Fastboot page, I have to run Fastboot, and that's the bottleneck.
Right.
It is true, because what does he say? He says if it was important to you, you would control it.
Yeah.
And it's true. Like it's not important to me in Fastboot because if it actually did speed up the Fastboot responses, I probably would have custom code around the e-tag stuff, but I just use all the Express default stuff. So it's probably like, so it's like, okay, it's nice if it works, but yeah, it's exactly that. I don't care about it because by the time I have it, I've done 90% of the work.
Interesting. Yep. So yeah, if it meant anything to you, you'd be the one supplying it. Interesting. If you're still not convinced, you can go through this exercise again, but with a fully normalized SQL database. In that case, the /user API implementation reads and writes several tables, and what you have is a facade that allows you to access and modify one or more columns and specific rows in these particular tables, cross-referenced by meaningless internal IDs you probably don't see. The rules that govern these changes are fickle and unknowable, because you trigger a specific set of rules through a combination of URL, HTTP headers, post body, and internal database state. If you're lucky, your failed attempts will come back with some notes about how you might try to fix them individually. If not, too bad. Computer says no. For real-world apps, it is generally impossible by construction for a client to create and maintain an accurate replica of the data they are supposed to be able to query and share ownership of. That's kind of the end of this section. That, to me, I read that and I was like, wait a second. For real-world apps, it is generally impossible by construction for a client to create and maintain an accurate replica of the data they are supposed to be able to query and share ownership of.
So I think I agree with that, because when we start out our apps, that's true. Like the client's creating a user, it's doing store.createRecord user, save, that's a post. The for the most part, the client store and this database, they might be different, but the client store has everything the user needs, right? The client store won't have like the password hash, but the web app doesn't need the password hash, so it doesn't matter. But I think as applications get more and more complex, you're going to be posting records, and the server is going to insert those into the database and then also run some other logic. Like for us, when we like have video events, and then we roll up video events to video views. And so now, like the client can't maintain that on their own. They actually have to like go to the server and say, okay, just refresh all my data. Tell me everything I need to know about.
Right.
And I think that's what he's saying is we can't just have the client create things
and maintain
it. Yeah, it would have to constantly ask the server. Right now, is that fair? Like,
I think he's building up to because he's building up to an argument as that's what's the general solution to this problem, which has already been solved in distributed computing, but that we as web app developers aren't internalizing. But he's making the argument that like, if the idea of REST was true, then you do have access to cacheable resources that are stateless and request are idempotent. So in theory, if you assume all that to be true, then it should be actually pretty straightforward for clients to have the same versions of those stateless resources on their local data stores, and that you can derive your UI from that. But because of all these reasons why it's not true, basically the axioms of REST fall apart very quickly, and so it basically becomes impossible for clients to have the known set of data that they need, because of the cacheability problems that he talked about, because of the partial rows and the ways things change, and the fact that cache headers and e-tags don't solve any of those problems. And so if you're going into it saying, you think about how, like, when we think of Ember data, you are kind of trying to do that, right? Ember data is a local cache, and the way we think about it is it's a subset of the universe of data. And the higher level we get with our APIs, we want to declare which queries, which subsets of the data that our client needs in order to render. And ideally, you just know those things, and then you build your whole app from that. But if it turns out that some of those axioms are not true, then you're not really working with that data that you thought you were. And that's why you run into bugs like, the last write wins, because you didn't actually have a stateless resource. You didn't. You thought you did. What you had was a partial snapshot of a database row, and also one that changed over time. And so now you have a bug where last write wins, right? Or you're looking at stale data because you don't actually know. It's not actually an immutable resource. It's actually a mutable thing, and you don't know when it changed. And HTTP cache headers don't work. So like, basically, I think he's just saying, like, if the axioms of REST were actually true and maintained, you could actually build apps successfully in the way that we do, and we would run into these issues. But because policy is like actually the primary consideration here, it doesn't work. So like, basically, if you never had policy, let's say if you you literally exposed like SQL over HTTP, and all these problems would be like a lot easier, basically, is what he's saying.
Yeah. I guess you could represent, or
think about it, no partial data, or like no,
or just like, what is it, MySQL bin log, how it just syncs to other replicas. You could just do that to the client.
Exactly.
Yeah, it'd be a lot easier.
It would be a lot easier. Pretty interesting stuff. Okay, so this is like the next chapter. Regressive web apps. I can already hear someone say, my REST API is clean. My data models are well designed. All my endpoints follow the same consistent pattern. All the verbs are used correctly. There's a single source of truth for every piece of data, and all the schemas are always consistent. So what you're saying is that you wrote or scaffolded the exact same code to handle the exact same handful of verbs for all your different data types, each likely with their own models and controllers and their own URL namespace without any substantial behavioral differences between them. And you think this is good? As an aside, consider how long ago people figured out that password hashes should go in the /etc/shadow file instead of the now misnamed /etc/password. This is a one-to-one mapping, the kind of thing database normalization explicitly doesn't want you to split up with the same repeated, quote, primary keys in both, quote, tables. This duplication is actually good, though, because the OS's user API implements policy, and the rules and access patterns for shell information are entirely different from the ones for password hashes. Can you explain this to me?
Yeah. So this is okay. This is something you said earlier, where imagine if we had basically like a user for yourself and a different user table for users for admins and a different user table for like users.
You made different objects, like actually different domain models.
So there's etc passwd, which I think doesn't have any passwords in it. I think it's like users, groups. This is like channeling like my 14-year-old like Linux hacker. Yeah. I think there's like,
and that's why it says it's misnamed.
Yeah, and then there's etc shadow, which has the hashes. It basically has all the same data, but also with the password hashes. And like you if you go onto a system as a normal user, won't have access to the etc shadow file, but you will have access to etc passwd. You're like, holy crap, I can see everyone's password. No, you can't, because it's not in there.
Okay.
But I think that's the thing. It's like the data is duplicated in these two files, and you could say like, oh, I'm going to normalize
it. It's denormalized data. It violates third normal form. Like, why should we do that? There should be one source of truth.
Exactly. And and imagine like I'm writing these two files. It would be so much easier if it was, if there was, they were join record, or you could join by the user ID or whatever. But I guess
then he says this duplication is actually good, though, because the OS's user API implements capital P policy, and the rules and access patterns for shell information are entirely different from the ones for password hashes.
Yeah, so I guess I don't know enough about that, but I would basically think that like if I need to get what group you're in,
right,
I don't have to worry about like
exposing the hash.
Exactly, like the OS doesn't have to worry about writing something that says like, oh, you're a normal user, you only get this info back. It just says, hey, go read this file. It's all in this file.
Cool. You see, if APIs are about policy and not empowerment, then it absolutely makes sense to store and access that data in a way that is streamlined to enforce those policies, because you already know exactly what people are and aren't going to be doing with it. If you don't, that's undefined behavior and or a security hole. This is something most NoSQLers also got wrong, organizing their data not by policy, but rather by how it would be indexed or queried, which is not the same thing.
Yeah. I mean, I guess that's true with like SQL too. It's like we would organize data into tables.
So I think this will make a little more sense soon. This is also why people continue to write REST APIs, as flawed as they are. The busy work of creating unique, bespoke endpoints incidentally creates a time and a place for defining and implementing some kind of rules. It also means you never have to tackle them all at once consistently, which would be more difficult to pull off, but easier to maintain. So he's basically saying, like, if you just had literally a blob of data that's like mutable and basically the same from all perspectives, then the policy thing becomes really hard. Whereas since we're creating a new resource like an encode, which is by its nature private, we can define policy rules.
Example.
Yeah, we can define policy examples around our video encodes, which are fundamentally private resources accessible only to certain groups of people. And so we're thinking about the policy from the beginning, and even splitting up a model into two because one is like private and one's not. Now, sometimes we do that, sometimes we don't. But like basically there's more natural boundaries if you look at the schema of like a relational database there. Or even like pointing to a column and just saying like this is a private column, right? Like admin is true or false in this example.
Wait, if you go back to his where he said about NoSQL, he says people will organize data how it's indexed
or
and queried
but not rather than by policy.
By policy. So to make me just to like, okay, that makes me think that like what I really want right now, we organize data by how it's queried and how it's indexed.
Well, he's saying
all users go into the same table.
Well, but he's saying no SQL takes that to the extreme where all data is like
just
there's no structure.
Just
yeah, exactly.
Together.
Exactly.
I see.
And whereas at least the structure that we have with like foreign keys. Foreign keys are an example of policy, right?
Yep.
That's policy. That you can't just put anything in there that you want.
Yeah.
So there's the relational structure does add policy by nature to your data.
And then we also get pay as you go because
you're thinking about
you
the policy.
can only query the encodes table when we set up the encodes endpoint. And so we're doing all that stuff as we do it.
Yeah.
Okay.
So this is also why people continue to build REST APIs, as flawed as they are. The busy work of creating unique bespoke endpoints incidentally creates a time and a place for defining and implementing some kind of rules. So he's saying it feels like busy work, right? But every time you create a new API endpoint, you think about, okay, who has access to this? It also means you never have to tackle them all at once consistently, which would be more difficult to pull off, but easier to maintain. So it would be harder to try to say, to think about it at a holistic level. You want to be thinking about it at an individual resource level, basically. The stunted vocabulary of ad hoc schemas and their ill-defined nouns forces you to harmonize it all by hand before you can shove it into your meticulously typed and normalized database. So ad hoc schemas and their ill-defined nouns. He's talking about HTTP. And he's talking about the URL endpoints and basically this idea that what we call REST. If we're talking to a Rails developer and we're saying, okay, so which verbs are you going to expose? And okay, so you're not going to expose like delete because you can never delete that thing, and you can only get a single. You can't get the collection. So we're already talking about policy at that point.
Yep.
That's what he's saying. It forces us to harmonize it all by hand before we can shove it into our typed and normalized database.
Is a thing where how we talk about like making a resource to like publish a post? Like a post-publish resource,
publication or something.
Rather than just updating the post field because we're trying to fit in this world of verbs and nouns.
I think that's even beyond it. I think he's saying something similar, which is just if we were to say, all right, we're going to expose favorites on the site. Okay, how are we going to get favorites on our videos? How are we going to do it?
Okay,
we're going to say, okay, so you can get favorites. Favorites are going to be table. What do they point to? A person? Okay, who has access to favorites? Maybe you have your right.
Yeah.
All that discussion is saying that we're tackling this as we go. He says the superfluous exercise of individually shaving down the square pegs you ordered to fit the round holes you carve for yourself has incidentally allowed you to systematically check for woodworms. So, right, the whole first part of the article we read is saying basically how like unnatural of a fit these notions of the stateless RESTful resources are for what we're doing, because it's actually a lie. But in the end, we keep doing it because it allows us to check for woodworms, right? It's actually enabling us to have a sensible policy on the server resources that we expose.
Yeah.
So he's saying like there's all these reasons why it doesn't make sense, but at the end of the day, like the pros are the policy aspects, which is kind of his whole thesis, which is like they're all about policy, actually, APIs are. And so that's why we continue to do this.
So this gives you every resource you add, it's like a checkup for policy.
Yeah.
Where you get to just think about it. Yep. Okay.
Yeah. It has nothing to do with REST or even HTTP verbs. There is no semantic difference between sending a patch request to /user/1 with a JSON payload of name Jonathan Doe and update table users set name equal Jonathan Doe where ID 1. There's no semantic difference between those two, right? It's an SQL statement that updates the name of a user versus a patch request with a JSON payload. The main reason you don't pass SQL to your Rails app is because deciding on a policy for which SQL statements are allowed and which are not is practically impossible. At most, you could pattern match on a fixed set of query templates, which, if you do, would mean effectively using the contents of arbitrary SQL statements as enum values using the power of SQL to express the absence of SQL.
Whoa,
the aristocrats.
Hold on. We're JavaScript developers. We know how to walk ASTs.
Exactly.
Okay, so we can do so much more with those SQL statements.
But there is an entirely more practical encoding of sparse updates in whatever flavor of tree you prefer. And the word whatever is in JSON curly brackets. The word flavor is in angle brackets, React component syntax. Of tree you prefer is in Lisp dialect nested S expression. So then he has here a post to API update so he has a post to API update. So API update is a generic endpoint. And the payload is a JSON document, and the root is user. And then the root of that object is 1. And then the root of that is name, colon, and then key is $set, value is Jonathan Doe. So basically it's a JSON object with basically the table name, the row ID, and then what values are being updated, and the operation, which is set. So it's just a fake syntax he made up. Like if you just posted this JSON to /update, then look how much easier, first of all, this is to verify against your policy, right? As opposed to an SQL statement, right? If you just give me SQL and you tell me verify, this literally has like the resource, the ID, and then the operation in the field. And that would be super. Anyone of us could do that and write some code that would verify that against the authentication roles of the client. He says it even comes with free bulk operations.
Yeah.
You just look at this and you're like, oh yeah, you could just do user and then like this. You could just put them all there, all the operations you want to do. Validating an operation encoded like this is actually entirely feasible. First, you validate the access policy of the individual objects and properties being modified according to a defined policy schema. Then you check if any new values are references to other protected objects or forbidden values. Finally, you opportunistically merge the update and check the result for any data integrity violations before committing it. You've been doing this all along in your REST API endpoints. You just did it with bespoke code instead of declarative functional schemas and lambdas like a chump. If the acronyms CRDT and OT don't mean anything to you, this is also your cue to Google them so you can start to imagine a very different world. One where your sparse updates can be undone or rebased like Git commits in real time, letting users resolve any conflicts among themselves as they occur despite latency. It's one where the idea of remote web apps being comparable to native local apps is actually true, instead of a lie an entire industry has shamelessly agreed to tell itself.
Okay.
You might also want to think about how easy it would be to make a universal reducer for said updates on the client side too, obviating all those Redux actions you typed out. How you could use the composition of closures during the UI rendering process to make memoized update handlers, which produce sparse updates automatically to match your arbitrary descent into your data structures. That is React's cursor and its ancestors, except maybe reduced to 2.5 hooks and some change, with all the same time travel. Have you ever built a non-trivial web app that had redo, undo functionality that actually worked? Have you ever used a native app that didn't have this basic affordance? It's entirely within your reach.
There's a lot there. Yeah. But yes, I mean, no, whatever. I feel the pain.
Right.
Whatever.
Right. Super interesting, right? So, okay, CRDT and OT.
I don't know what OT is.
Operational. Let me Google it real quick. Go ahead.
CRDT, what does it stand for? Conflict.
CRDT. Conflict-free replicated data type.
I looked into these at TED. We had an issue where we had a bunch of services and they'd all everything would want to go through one service and then it would send its writes off to another service. It was very easy to get these two things in a bad state. And so I looked at these and they're basically like data structures where I'm gonna just give the
spitball,
it's like the time of the operation doesn't matter. The order of the operation doesn't matter. So you can imagine like an email client, it would have like all email messages. And then you would want to track like what's read and what's unread. And you would think like, oh, I would update the email message ID, like I'd update a Boolean to be like read or unread. But instead of doing that, you just have like another bucket, another array of like read emails. And then like you push IDs into that. It doesn't really matter. Like the order doesn't matter. You're never going to get a last write wins thing here. Where like if I'm updating red to true but body to this, and you update red to true but your body is stale, there's never going to be that problem. You can like keep going. Like what if you like unread? What if you mark a message as unread and then you read it? Like
it's just new operations.
Yeah,
it's just logs being appended to a data structure.
Yeah.
Immutable.
Yes. I guess it was, it's all immutable,
It's
right?
all
because
immutable.
you don't have the last write wins thing.
There's no stateful artifact. I mean, the entries are stateful, obviously. Like the set of all entries is stateful in a sense, but they are, each entry is immutable, like a bin log in SQL.
Yes. Okay.
OT is operation transformation, which I just Googled real quick and was basically saw that it's like the basis of like Google Docs. Or collaborative editing, which is exactly the same kind of thing you're talking about, which is they had this example where like they show a document and you start changing it and you just see new things like position 5, delete, position 8, add an E. So it's the same. It's all the similar idea of a log.
I think
of operations.
That was like the last example of the CRDT. It was like, how do you build an editor? And I think someone did make one that was like, it was really old. It was like sub ether edit or something. There's like some old school editor that had this, and that's how they did it. So interesting.
Super interesting.
Yeah.
I mean, to me, these last two paragraphs here, thinking about a web app where it says one where your sparse updates can be undone or rebased like git commits in real time, letting users resolve any conflicts among themselves as they occur despite latency. Like that sentence, that's one hell of a sentence.
Yeah.
I mean, think about that. And again, as something as simple as editing our blog post, a blog post of ours on two computers, two clients.
Right. And the latency stuff, I guess this is now, again, making sense to what you said before, but latency, like if you're offline.
Yeah.
If you don't have the latest data.
Yeah.
Yeah.
And, Git is incredible in the sense that you are never like, oh, wait, no, I have to make sure. Oh, did it save? Like, am I connected? Like, think about all the things you don't have to worry about.
That's very true. How often do you do something at SPA and then you refresh the page? How often do you do that in Git?
Yeah, never. The answer is never.
Yeah.
Or even typing on your notes app, in OS X. And do you refresh? Do you even think about if the thing's not? You don't think about that stuff. Imagine it. You can start to imagine a very different world. One where your sparse updates can be undone. It's one where the idea of remote web apps being comparable to native local apps is actually true instead of a lie an entire industry has shamelessly agreed to tell itself. I just think this is like mind blowing. Like it's one of those things you read and you're like, oh, we've been doing everything all wrong. All right, let's see if we can actually get through that. I actually think we're going to be able to get through this. So basically, the last chapter here. So it's called GraphQL. I misread this the first time. I thought, oh, GraphQL, like chapter 3. GraphQL. It's GraphQL. It'll make sense why, based on what we just said, right? The OL, which was the OT is operational transform. GraphQL. So, GraphQL. Sorry, GraphQL. All right, chapter whatever. GraphQL. If you haven't been paying attention, you might think GraphQL answers a lot of these troubles. Isn't GraphQL just like passing an arbitrary select query to the server, except in a query language that is recursive, typed, composable, and all that? And doesn't GraphQL have typed mutations too, allowing for better write operations? Well, no. Let's start with the elephant in the room. GraphQL was made by Facebook. That Facebook. They're the same people who made the wildly successful React, but here's the key difference. You probably have the same front-end concerns as Facebook, but you do not have the same back-end concerns. The value proposition here is of using a query language designed for a platform that boxes its 2+ billion users in, feeds them extremely precise selections from an astronomical trove of continuously harvested data, and only allows them to interact by throwing small pebbles into the relentless stream in the hope that they make some ripples. That is, it's a query language that is very good at letting you traverse an enormous graph while verifying all traversals, but it was mainly a tool of necessity. It lets them pick and choose what to query because letting Facebook servers tell you everything they know about the people you're looking at would saturate your line. Not to mention, they don't want you to keep any of this data. You're not allowed to take it home. All that redundant querying over time has to be minimized and overseen somehow. One problem Facebook didn't have, though, was to avoid busy work. That's what junior hires are for, and hence GraphQL mutations are just post requests with a superficial layer of typed paint. The graph part of the QL is only for reading, which few people actually had real issues with, seeing as get was the one verb of REST that worked the most as advertised. That's pretty interesting. The graph part of the GraphQL is only for reading, which few people actually had real issues with, seeing as get was the one verb of REST that worked the most as advertised. So the reason it works the most as advertised because you probably do have a lot of stateless resources in your system that a get request would be idempotent and cacheable. Now, one thing this made me think of is one of the reasons GraphQL was created was to improve upon get so that you only get the data that you need. And a lot of times when we read or see people talking about GraphQL versus REST, it's like, oh, now you have to do your server has to know what the client wants. But, as we've seen with JSON API with the includes, that is a way to customize that and still maintain cacheability and all that stuff and not have to go to GraphQL. So I think that misses some of the important conversation aspects of the conversation. You can have REST, and in a sense, GraphQL is still it's really the same thing. It's not really about. That's kind of his whole point. Is what we're talking about here is not about verbs or even REST or HTTP or anything like that. So certainly GraphQL gets you a ton of flexibility and all this stuff. But he's basically saying, he'll kind of continue talking about it. So. Retaining a local copy of all visible data is impractical and undesirable for Facebook's purposes. But should it be impractical for your app? Or could it actually be extremely convenient, provided you got there via technical choices and a data model adapted to your situation? In order to do that, you cannot be fetching arbitrary sparse views of unlabeled data. You need to sync subgraphs reliably both ways. If the policy boundaries don't match the data's own, that becomes a Herculean task. I feel like there's a lot here.
On the first part, yes.
Retaining a local copy of all visible data is impractical and undesirable for Facebook's purposes. Okay, agree. Makes sense.
Sure. I work on an app where I have to go to the back end to do all these calculations because I don't have a good way of maintaining a local copy. There's not that much data. I mean, there's thousands, hundreds of thousands of rows. I don't really have a good way of getting it. But in reality, it's not that much. And if you could tell me that there was a way I could have all that data locally, it would absolutely make my life easier.
Right.
So that I'm excited for this.
Right. Could it be extremely convenient provided you got there via technical choices and a data model adapted to your situation? So, and I think this is going back to some of the log-based immutable logs of data idea where, our GitHub repos have a copy of the entire database locally. That's what a Git repo is. And it's extremely convenient for every single client to have a copy of the database in a way that is, it's replicatable and it can be updated over latency, right? Ignoring latency. So that's basically what he's talking about. And if you imagine that we conceived and wrote the data storage for our web apps in the same way, could that be convenient? Yeah, hell yeah, that could be convenient and powerful, right? In order to do that, you cannot be fetching arbitrary sparse views of unlabeled data. You need to sync subgraphs reliably both ways. Again, the Git analogy here makes this super clear, right?
Yeah, I mean, I think even simpler, just your Ember data store, you want to be able to sync, a group of models or a graph of relationships. You don't want to just say, show me all the first names and those people's blog post titles.
Right. But you can't, it says, if the policy boundaries don't match the data's own, that becomes a Herculean task. Right. So why can't you just git pull? It's because you have access to the entire thing.
Yeah.
It's one policy. Do you have access to this repo on GitHub? Yes or no? Yes. Therefore, you get the whole thing. If you do a get to /user/1 and you only get 3 fields of it because you're not the admin, how do you sync the whole thing locally whenever it changes? How can you do a git pull? That's why this becomes a Herculean task, because our API has all this policy spread everywhere. And the idea of getting the full database is like, it's just not how we even think about going about this.
Yep. And then as soon as you solve that, now you have to solve it for the push.
Right. And the caching part too. Like, how do you have stale data and all these things. Which is why like the kind of APIs that you and I talk about with Storefront and other things with these SPAs that we build is like, really you want, what this nudges you towards is a query that just is like, subscribe to the back. So you say, fetch me all users in my team, including all video views, and render them right here. And if you can do that like in a load component in the template, then you actually have access to that query, and you could write it in such a way that the back end, anytime that query changes, it gives you the latest data. And yeah, that's kind of like what you're nudged towards. But that feels like it's a lot of work.
Yeah.
To know what's changed, to know what's different, to know what's stale, to know if something that I create over here affects the table right here, right? Like the app you're working on. You have a table, you filter it by, you're on page 1 and you filter it by, to be deleted. And then you create a new thing or mark a thing as deleted in a form over here. Should that affect this? I mean, not having the whole universe of data is what makes all of that stuff super hard.
Yeah.
Because you're like working with this fake derived subset, right? Whereas again, like the Git analogy is just so clear how powerful that is, right?
Yeah, it's very easy to based on the example you just gave to be like, well, that's like a product decision, right? It's a product decision to figure out what should be shown on this table when something else happens on another page. And when the product decision is made, then you can write some code to... You can,
but that code's going to suck.
Yeah, well, that's the thing. It's like, imagine if you had this layer that just knew you could just pull in...
There's always a product decision.
Right. So imagine you're starting with all the data.
Yeah.
And then you can build the product decision on top of all the data that you have, rather than, the product decision is made, now I have to figure out how to synchronize this data.
Right. And we try to approximate that by using Ember Data's cache. And that's why working on like a React app or other apps without this notion of like a canonical version of the server-side records in the client in a cache makes this stuff like, we don't even know how to think. Like, that's just so unbelievably useful and convenient to have that on the client and to derive your UI from that we can't even imagine building an app without that. But the parts where it falls apart is where it gets hard, right? Where you're doing a derived calculation, you don't have the universe on the client. So you're getting page 1, and now you're adding a new to be deleted record. Does that change page 1? I don't know. I have to ask the server now.
Yeah.
Right? That's exactly where it falls apart.
Yeah.
But in every page we possibly can, if we can get the universe of data that would be relevant for that, we do it, because that makes it way easier. And that's why.
And like get the client knowing that if I create a user, they know how it enters into the universe of users.
Right.
And then you can make those product decisions off that.
Right.
Yeah.
Right. What's particularly poignant is that the actual realization of a GraphQL backend in the wild is typically done by ... hooking it up to an SQL database and grafting all the records together. You recursively query this decidedly non-graph relational database, which has now grown JSON columns and other mutations. Different peg, same hole, but the peg shaving machine is now a Boston Dynamics robot with a cute little dog called Apollo, and they do some neat tricks together. It's just an act, though. You're not supposed to participate. Don't get me wrong. I know there are real benefits around GraphQL typing and tooling, but you do have to realize that most of this serves to scaffold out busywork, not eliminate it fully. while leaving the insert, update, and delete side of things mostly unaddressed. You're expected to keep treating your users like robots that should only bleep the words get and post, instead of just looking at the thing and touching the thing directly, preferably in group, tolerant to both error and lag. This is, in my opinion, the real development and innovation bottleneck in practical client-server application architecture, the thing that makes so many web apps still feel like web apps instead of native apps, even if it's Electron. It makes any requirement of an offline mode a non-trivial investment rather than a sane default for any developer. The effect is also felt by the user as an inability to freely engage with the data. You're only allowed to siphon it out at low volume, applying changes only after submitting a permission slip in triplicate and getting a stamped receipt. Right? Because you have to, to request, verify, response, as opposed to, how do you feel about your data in Git, right? You have the entire thing. You can literally atom.git and see the entire structure. Mm-hmm. You have the whole thing. Bureaucracy is a necessary evil, but it should only ever be applied at minimum viable levels, not turned into an industry tradition. The exceptions are rare, always significant feats of smart engineering, and unmistakable on site. It's whenever someone has successfully managed to separate the logistics of the API from its policies, without falling into the trap of making a one-size-fits-all tool that doesn't fit by design. Can we start trying to democratize that? It would be a good policy. Pretty interesting, right? The exceptions are rare, always significant feats of smart engineering and unmistakable on site. So Google Docs, let's say, right? Mm-hmm. As an example. Something that doesn't feel like a web app. Can we think of others, right? Basically, he's saying the parts that do not feel like this normal, very limited, restricted get request response with partial data and bugs. When's the last time you used Google Docs and had a bug in the core editing flow, right?
Right.
It's like, it feels like a different part of the application. It feels like a native app.
Yeah.
Maybe like I haven't used Figma a ton, but like I was working the other day and using it, and it's like, it's crazy. Like, and however the data is consistent, I wouldn't even know what to do. It's like written in C++, I think, and like compiled in Scripting. It's like faster than Sketch, way faster.
Really?
Yeah. Oh yeah, it's crazy. It's all in the browser. It's insane. But like, I think that's exactly what he's getting at. Like, there are those few web apps you can think of that do not feel like web apps, and it's like, this has a big part to do with it. They've managed to, this has a big part to do with it. If you have all the data locally, you can build things that are completely separate. Then, it's a completely different category of experience.
Yeah.
Which is why, like, when Ember and Ember data works so well, it works so well. You have the data. It feels like magic. You have the data locally. It feels like a native app. It's awesome. That's what drew us to this whole, this whole approach to building web apps.
Yeah, and also too, like if you were building an app that didn't have to synchronize data, just think about how exciting would that be? Yeah. Seriously, how exciting would that be? It would be super fun to build.
Yes.
And you could get away with some crazy stuff, like some really, really nice UI there.
So. Totally. Yeah. One of the apps I built at TED Ed was the lesson creator thing, and we did save data, but like it was very much like an offline kind of thing where you're just adding, we could do anything because it was just like, it was all, Ember data was a source of truth. And then you just save it at the end, boom. And it's like, that really, really made things a lot easier. We've talked about this before, maybe more than a year ago, like Ember data could be built on a log-based storage underneath. And you do want at a high level, the stateful API. You want to say like user.isAdmin. And if underneath there's 5 operations that, update that to and from, you don't want to have to think about that when you're working at the high level. But if that's what the data storage was underneath, like it feels like it buys you so much without sacrificing a lot on the high level API side. You can just sync log. You can say as of, how up to date is the client. Oh, we have log entry 1546. Okay, the server is, a few entries ahead or whatever. You can just roll it into it. You can make operational changes on the client if you're disconnected and push those back later, just like MySQL would. I mean,
it makes it easy for the client. I mean, maybe, but I'm going to say this. It makes it easy for the client to resolve conflicts because you get a few new log entries and one of the entries is on a thing that you're editing. And you can say like, okay, what do you want to do here?
Right.
And you can make a decision right there.
Right. He says that earlier, right? Something about that where the clients can resolve it on their own. So like instead of you saving in last write wins, you just see,
Yeah, this has been changed.
What do you want to do?
Keep that one, throw it away. What? Yeah.
I mean, I thought this article, that's the end of the article. He says, can we start trying to democratize that? It would be a good policy. So I think this is a really thought-provoking article, and it's like worth thinking about what would it look like. Again, he says GraphQL is good. There's definitely concrete benefits. We've seen it even working in Gatsby. It's incredible. But it's incredible for different reasons. And it doesn't solve these data loading and persistence and stale data problems, which takes up so much of our thought process.
Oh, yeah.
So much of the problems that we have, folks we consult with are having, so much of what makes SPA development complex. And it's not really addressing those. It's also interesting, like, the graph part is more about the reading. It's only about the reading. And graph versus non-graph is not really relevant to the conversation of, do I have the universe of data or not?
Right.
Those are separate things.
Right.
Graph makes sense in the sense that you're building like a nested tree and you want like something that's like that to make it easy to paint to the screen. But like, okay, when does that thing become stale? What happens when all that is completely separate? So I thought that was pretty interesting kind of take away from this as well.
I also think this is like, I think this is true in Ember, but there's like a lot of criticism of GraphQL. And I think it's good to be able to say that like GraphQL is really good because of the tooling. Tooling is awesome. Mm-hmm. But here are some parts where it's like, it's not that different from JSON API.
Yeah. And it's not, and neither of them are solving the actual hard problems.
Right.
That's really the thing.
Yeah.
It's that they're neither solving the hard problems. I think it'd be interesting. I know Orbit has some of these ideas in it, but I'd be interested in seeing, where are some other popular projects that are thinking about this. We've even talked before about like, what would it look like for Rails to use this under the hood? Because it could, it could do that.
Yeah. I'm going to go back to something in the article about like how you organize data. Mm-hmm. And it's like, really, like if we use Orbit, I don't see us getting rid of all the API policy on the back end. But that's the thing that sucks.
That's the problem. That is the problem. You can't make a separate resource for every every subset of resource that is cacheable, and you don't have to worry about becoming stale. Like that's not going to happen. Yeah. So like the front end stuff won't. Yeah.
It's almost like I want like a safe API framework that's almost like for every user that I have, it's like they get a whole new database, something like that.
Right.
And the things that should be shared just happen magically to show up in both databases tables.
Yeah.
Right. So like for EmberMap, we'd have, every user would have their own EmberMap entire database that the front end could just download.
Right.
And things like videos would just automatically be inserted into every single thing. But like, that's the kind of thing that like, hey, I got a put request from this user. Okay, I can just write it right to the database.
Right.
I don't have to do any policy checking because I know they have their own database.
Right. So you have one reducer, like you said.
Yeah.
You have literally one reducer. It just takes like the data and the operation and the resource and saves it. And like that's it. And returns the new database. That's like your one reducer that you write.
Yeah. So that would be like thinking about my backend like that. And if I could eliminate all that policy stuff. Because like one of the things with we use JSON API resources and everything's writable by default. And so like we layer on Pundit, and there's a gem that marries Pundit to JSON API resources and locks down everything. And like that feels really good when you get that, working. Like it feels great. Everything's locked down. You have these nice declarative Pundit policies. But like after a year or 2 years of having these, I'm still writing a lot of policy code.
Mm-hmm.
And I have no good way of like synchronizing the two. Like I can't, in my apps, I can't have once the client gets the full backend, they can just do all everything themselves.
That's the thing. I mean, policy might continue to be a very complex part of the application process, like development process. Like business logic is hard inherently, and it might always be so. But what's not, doesn't have to be hard, is the updating and the reading part. What he said, where he said when your policy boundaries don't match your data boundaries, then you have a ton of, basically he's saying you have a ton of incidental complexity, which is like where all this stuff comes from. But if you could just give me, like you just said, a version of the database that I have complete access to and I can go to town on it, think about that. Like if you do the hard work of defining what that boundary is, then you get all of the CRUD operations for free. Like CRUD is not hard in SQL because they just give you a database and like you don't have to do anything, right? So if I could just give you like a database that you have access to, then you get one, you write one reducer. You don't worry about stale data. Like that's all that to me seems like a pretty awesome model where you are defining what the policy boundaries are and the data boundaries are derived from that, like in a very airtight way. And the querying and writing interfaces are like uniform across all those things.
Okay.
So, because right now you have to do policy, but then you also have to say, okay, well, what about if the client's data is stale? What if they query something and it's not, it changes, or all of the data concerns are still there, even though you've done the work of defining the policy. And he's saying like, if you could define the policy and the data boundary shared those policy boundaries, just like with Git, like if you have access to Git, then it doesn't matter. Like it doesn't matter. The policy boundary is the repository. And so all of the operations are just exposed. You have control of the data. GitHub doesn't have to worry about us doing anything because we downloaded the Git repository, because that is the boundary. The boundary is the same thing. Once you're behind that boundary, you have access to everything. And so the Git interface is like for you, right?
Mm-hmm. Okay, I'm just going to completely ignore everything you just read.
No problem.
Given that our API does have, it took us a while to get there, and it was a pay-as-you-go thing, but given that we do have a policy around all of our endpoints that I feel confident in,
yep,
why can't we just start accepting arbitrary?
I mean that is kind of what we're trying to get closer and closer to. But the problem is with the storage. The problem is that we think of objects as stateful snapshots, or like not even. Like they're just, they're like that's part of the problem, right?
Okay, so in order for me to like sync a database, like I literally have to sync the database. Like I have to like go through every table, go through every row and sync that. Where like,
I think it's like, okay, like premise one, log-based storage enables like all these amazing things. Undo, redo, low latency, conflict resolution, all these things, right? Premise two, like when we started building APIs and we said you can only access like the name column and not the email column, we basically said you're getting a sparse snapshot, a sparse view of some data. And then like conclusion is like, we don't get the benefits of the logs because we are by definition saying you have sparse view into the data. And like log is like literally a log is like the entire thing that's happened, the entire history of everything that's changed. So what he's saying is like, you kind of flip that and you say, okay, if we assume that log-based storage, which is essentially saying the entire set of data and all the operations over time, is something that enables good UI development, and then B, like we see sparse fields are not the way to expose data. It's like through policy boundaries. Then the conclusion is like, okay, define your policy boundaries, buy into the log-based data model, and then boom, you get all these things that fall out from it. And it's like, that's not what anyone's doing. And even he's saying like, okay, I get it. GraphQL is awesome, but it's not tackling this. Like you're still getting sparse view of data, and you're still dealing with like stale data and all these issues.
I mean, hey, maybe sparse view of data is fine if that. Imagine you have a log system, and then as you generate these logs, like policies come into account
and like tell you which log entries you have access to.
Yeah, or like every time someone does a write, I just generate a log for all 2,000 users in my database.
Yep.
And then their log, I know their log was generated by my policy, and that way the policy does match the data.
Yep.
then
that's interesting. Also, I think like it's so easy for people to be like, oh, it's so much data. Like you have to query a subset of data because it's a client and it's expensive and all this stuff. But this is where he's saying like Facebook had this particular problem where the news feed was literally the limiting factor was the amount of data going over the wire. Mobile devices were slowing down, all that stuff. But is it true for your app? Most apps it's not true for. Like most apps it's probably not true that getting the full data. Like if you think about making a notes app in the web or whatever, I mean, eventually you obviously can't get the full data, but like for what you're looking at, let's say, instead of starting out by saying what's the sparse view that we need, instead of saying what's the whole history of this thing, give it to the client in the same way you give them a Git repository, and then you solve the scaling issues later, right? Like Git comes first, Git large file storage comes second, whereas we're all starting with like the opposite. And so what would it look like if we started with the Git model basically first? And it's not about, oh, but you're sending too much data or you only need a little bit of it. It's about, let's start with the full database, which by necessity means defining the policy boundaries. So pretty fascinating stuff. All right, well, I think we're about out of time this week, but if you liked this, it was kind of an experimental episode, then let us know. Maybe we'll find some other really interesting articles. Actually, I just saw that I think this guy, again, this is Steven Wittens, and his website is acco.net, acko.net. We'll put a link to this article in the show notes. And I just saw he has a new article called Model View Catharsis. MVC was a mistake. That was published on August 10th. So that sounds like it will be very interesting. I'm looking forward to reading that. But if you want us to do this again or have any questions about this, any follow-up discussion points, be sure to let us know on Twitter.
Yeah, and in the meantime, I'll be rewriting our backend to git commit every time it gets a post request.
Didn't Ed do like a storage version for Card Stack that
used Git? Yeah,
literally Git storage. So the whole point was like undo and redo for free. Maybe that's a good way to experiment to start. It's already written. It's not a bad idea.
And it's an experiment. Like,
it
doesn't need to scale, right?
Yeah, pretty interesting.
Yeah.
Cool. Thanks so much for joining us, and we will see you next time.
See ya.
Bye.